Irrigation management has sometimes been compared to managing a checking account, where you have to keep track of deposits and withdrawals to make sure you don't overdraw. I'd like to talk a little bit about some of the withdrawals we have in an irrigation situation. When water's in the soil, it can leave the soil in only a couple of ways. It can evaporate from the soil surface, it can be integrated into the plant as part of the plant tissue, or it can actually move through the plant and be evaporated from the leaf surface into the atmosphere. We lump all of these together in a term that's called evapotranspiration, and that is used to describe how water leaves the soil, and it's basically the withdrawal part of our equation. Now, evapotranspiration depends on several factors. It depends on plant size, and it's just common sense that a 6-inch tall corn plant would not transpire as much water as a corn plant that was 6 feet tall. That makes sense to us. Also, things that influence evapotranspiration would be climatic conditions, temperature, humidity, the amount of wind, solar radiation, those things. One way that scientists have been able to get a handle on evapotranspiration is by using devices called lysimeters. And a lysimeter is essentially a large pot, several feet across and several feet deep, that's mounted in the soil at soil level, and underneath the pot is something that allows the scientists to weigh the whole thing. And so by weighing it after irrigation and before irrigations, they're able to determine how much water was added and how much water was actually lost through evapotranspiration. And when you take that information and compare it with meteorological data like temperature and humidity and etc., then you can start to correlate those things and determine how climatic conditions and plant growth stage actually affects the amount of water that's being released. So from all of that, we now are able to predict evapotranspiration simply by using environmental data. So if we have a weather station that will record all of the information we need, we can then take that data and using crop coefficients, which are basically multiplier factors that have been developed using this lysimeter data, we can now predict how much water a crop is using. And so in every state there are weather stations that are generating the data, and in nearly every state there are places where you can go online and actually dial up either daily or weekly or monthly evapotranspiration. That would tell you what withdrawals have been made from the account and how much water needs to be applied. Here in Utah, Utah State University Extension has a website that deals with crop weather, and you can go on there and for many parts of the state pull up weekly evapotranspiration. In Colorado, you would contact your land-grant university, which would be Colorado State University, or your local extension office, and they can refer you to websites or other places where you can get ET data or evapotranspiration data for your particular area. In Wyoming, you can contact the University of Wyoming, which is your land-grant university, or your local extension office, and they can either provide for you or refer you to places, such as websites, where you can get evapotranspiration data for your locality. There are also publications that have been developed that are based on long-term averages. For example, in Utah, again, there are publications for every county that talk about crop water use, and you can find tables on there that would tell you that on an average year, alfalfa in June in this particular county would use a certain amount of moisture. And from that, then, if you know how much your crop is using and have some feel for how much you're applying with irrigation, then it becomes much easier to effectively schedule water applications in the field.